Xin chào giáo sư, là hy vọng giáo sư có thể nghe được tiếng Việt rõ ràng, bởi vì và rất cảm ơn giáo sư đã tham dự chương trình hôm nay cùng với hội. Có lẽ là chắc là một những hoạt động đầu tiên của giáo sư với hội. Hy vọng giáo sư đã hiểu hơn về việc là các hoạt động tiêu chí của hội như nào. Thế để cũng không dài dòng thêm nữa thì cũng xin giới thiệu buổi các gọi là buổi talk đầu tiên của giáo sư, gọi là opening keynote. Thì the title là The UK Manufacturing Research Landscape, Some Personal Reflection. Cái title rất là hay, Some Personal Reflection, là rất nhiều người muốn quan tâm đến cái vấn đề đấy. Thì có lẽ là nếu phần introduction về bio của giáo sư thì rất là dài, vì có nhiều thành tích và cũng như thành tựu. Có lẽ tôi điểm qua nhanh một tí để cho mọi người biết. Thì giáo sư hiện nay là giữ chức gọi là Chair of Engineering tại trường đại học University of Birmingham, và có lẽ dịch sang tiếng Việt hơi chậm, thì tôi đọc tiếng Anh cho nhanh vậy. Where he started his career as a lecturer in robotics and control engineering, following undergraduate and postgraduate study at the University of Canterbury in New Zealand. So he returned to Birmingham in 2011. And he was a professor of computer control and manufacture and director of the Manufacturing Engineering Center at Cardiff University. His research is in the area of intelligent system. So intelligent system, robotics, autonomous system, and advanced manufacturing. And the last one, remanufacturing technology. I think that one is very exciting as well. He has published over 600 technical papers and books, and has graduated more than 100 PhD students. Okay, more than 100 PhD students. And he is a recipient of several awards, including 5 prizes from the Institution of Mechanical Engineers, and a Lifetime Achievement Award from the World Automation Congress, and Distinguished International Academic Contribution Award from the IEEE. He's a fellow of the Royal Academy of Engineering and the Learned Society of Wales and the Society for Manufacturing Engineers, and the institution, the IET, and the Institution of Mechanical Engineers. Oh, sorry, I have to just flip over all the things, but Professor Pham, thank you again and welcome you to the stage now. It's all yours now. You can start. You can share the screen.
Thank you very much, Professor Huân. And thank you to everybody for attending the event. Please excuse me, I can understand you very well when you speak Vietnamese, but my spoken Vietnamese is very rusty. I left Vietnam more than 50 years ago, and my vocabulary is limited. So although I can speak, I don't speak it very fluently. So I hope that you will forgive me for speaking in English.
Absolutely fine. We already mentioned at the very beginning that all speakers feel free to speak in Vietnamese or English. We are all okay with that. So please.
Thank you very much. So I'd like to share the screen now. Let me see. Screen. This one. Share. Can you see my screen yet?
Yes, we do.
Okay, so I will maximize it. It seems. Yeah. Okay. So, thank you again, Professor Huân, for asking me to speak today. At first, I would like to give you a few facts and figures about UK manufacturing to show you that it is still an important area of the UK, important activity of the UK. Then I'll take you through UK manufacturing research over the last 4 decades. This is my personal experience, so I'll weave into this description my journey. And then at the end, a few observations, personal observations, and I will conclude the presentation. So manufacturing in the UK is currently employing 18% of the workforce. This has declined from about 30%, and in fact above that, from 30 years ago. So it's not 4 decades because I don't have the data for the 1980s. The data comes from World Bank. So the first figure was about 30% in 1991, and now it is 18%. So there is a decline in the percentage of people employed in manufacturing, which is not by itself bad, because in the UK, as you know, employment rates are high. Now, most people are employed. The unemployment rate is still low, 4 or 5%. So very low compared to the 80s. So by itself, 18% employment is not bad, not bad, but we don't want it to decline, because manufacturing is a very important activity. As you will see in a minute, it contributes a lot to the wealth of the nation. Now, the trend in decrease in employment in manufacturing is global, at least in the West. So United Kingdom, you see that it is declining and stabilizing a bit. The same with United States, the same with European Union. Now, if you look at manufacturing as a percentage of GDP, then the decline is also very sharp. Now it's only 9% of GDP in the UK. It started, according to my data, at about 17%, almost 17%, 30 years ago. So this is important. This is more serious than the decline in the number of people working in manufacturing. Now, we need not be too worried, because we are not alone here. The United States also sees a decline. The EU also sees a decline. Now, as Vietnamese, we would be interested to see what is happening in Vietnam, what has been happening. And you can see that it is not bad. Vietnam is employing 17%, or is producing 17% of its GDP from manufacturing, compared to 9% here, 11% in United States, and 15% in the EU. But please don't be overexcited, because when we look at the actual GDP, then the GDP of the UK is 10 times that of Vietnam. Now, Vietnam, I think, has 97 million people. The UK has 67 million people. So we deserve to have much more in Vietnam. So just for comparison, you can see that GDP in the United Kingdom is, fluctuating but stagnating. It's the same with Europe. So there is a problem in terms of productivity in the UK and in Europe. That's why productivity is a very important point. And this we will return to a bit later. So manufacturing is very important. You can see that it is about 9% of this large figure, so 2,700 billion pounds is the value of the UK economy, and it's 9% of this, let's say 10% of this. So it's a very large figure. So that's why the UK is focusing on improving its productivity. It's focusing research in order to improve productivity in manufacturing. The UK still produces about 1.8% of the world output in manufacturing. So it's not an insignificant figure. But when you compare it with Germany, then we have a long way to go in the UK. Still quite a bit to catch up. And there's opportunity to catch up with Brexit and other developments. So now, my journey in the UK in manufacturing began at the end of the 1970s. I came to the UK in 79 from New Zealand. And in 1980 was my first experience with the UK manufacturing research. And in the UK, there was a 5-year program in robotics. The UK recognized at the time that we were behind other countries in terms of the use of robots, development of robots. So there was this program focusing on industrial robotics. It was a 5-year program, and please remember this was pre full economic costing regime. So 500K was worth quite a lot more at that time than it is now. So let's say my grant in this area, my first SERC is the predecessor of the EPSRC now. So my grant was 67K, and it was a 3-year grant, and I was able to employ a postdoc, you know, a person as a research fellow for 3 years. So you can see the equivalence there. So if you look at it now, to have a postdoc for 3 years, you probably need 400K. You know, so 67K was equivalent to 400. So you multiply this by 7. So it's about 3.5 million per year at the time. And it was during the 5 years, people realized that robots were only a component of manufacturing. Focusing on robots alone was not sufficient. And the successor to this program, by at that time SERC, but then it became EPSRC afterwards, was the ACME program, or applications of computers to manufacturing engineering. It was a program that started in 1984. So just as the robotics program was coming to an end, this ACME program started, and it went into the 1990s. I am not sure when it actually ended, but it was in the 1990s. It was a directed program. So like the robotics program, it had a director as robotics program. It was not called a director, it was called a coordinator. But for ACME, it was directed. So there was a director, a directorate, and they award funds. And it was a good time also to be part of the program, because if you had a good idea, you went to the director, you talked with the directorate, and they can arrange for you to get the grants quite easily. Although it was still competitive, it was easier than with normal SERC programs. The 3 areas that the program was concerned with were advanced production systems. So this is like the successor of the robotics program. It was more concerned with technologies of production. So robots were part of it, but not only robots. Then you have computer-aided design. That was also a very important part of the program. And finally, you have planning and control of production activity. Now, this is more organization, more management. So you see business schools getting involved in SERC type of projects. So you see people from business schools getting involved in projects like this. So you see supply chain projects, for instance, supported by SERC. And then there were other areas that I was not too familiar with, like infrastructure and methodologies for integration of manufacture. They were not the main areas. The 3 main areas are listed here. So that was SERC, quite a long-running program, probably 10 years. At the same time, the Department of Trade and Industry had its own program. supporting IT. So this is of interest to our colleagues in computer science. And one of the areas supported by the program is IKBS. So nowadays we would call this AI. This is more like expert systems at the time. It was very focused. The word expert system had a bad name, so people invented a new word in the UK called intelligent knowledge-based systems. So this was running almost in parallel with the ACME program. It was only a 5-year program, but it was the start of massive collaborative research projects. You can see it had 350 million pounds as a program, of which 200 came from the DTI and 150 had to come from industry. So there were large projects for the time. There were some 200 projects running with this kind of budget. So it was, for the 1980s, a large program. Now, this is of more interest to us because of our interest in AI, but there were other things in, say, VLSI, software engineering, and so forth. The EPSRC, after ACME, started to fund projects which were called innovative manufacturing research centers. Now, they realized, the EPSRC, they realized that certain groups were always successful at getting funding from them. So rather than giving them a small grant at a time, they say to these groups to get together and form centers, which would be funded for longer period, let's say 5 years, and maybe a renewal period of another 5 years. And they would give each group something like 5 million or at least 3-4 million pounds. And the groups were free to work on different projects. And so this innovative manufacturing research center program was born. It ran for about 10 years and it supported quite a few projects. And the total budget is also quite large. After this program, there was another program with a similar name and similar reasoning. Large group, large amount of funding, and freedom to operate with that funding. Then more recently, there are these research hubs. They have 7-year programs given again to large groups. So you see, big is important. It is important to have a big activity, and then you can get funding, large amount of funding. In the case of these hubs, 10 million pounds each, running for 7 years. Then very recently, another program known as the Manufacturing Made Smarter Research Centers, 25 million pounds for 5 centers, so 5 million pounds each. And running in the background is the CDTs. So they also fund some manufacturing CDTs, centers for doctoral training for PhDs. So quite a large amount of money from EPSRC, not all dedicated to manufacturing. But if you have an idea for a program in manufacturing, then you could go to this center, this program for support. They have calls. So at the moment there's no call, but hopefully in the future there will be calls and people can apply for funding under these calls. And then you can have networking grants, and there can be some large networking grants, 2 million pounds, for instance. You can run a network with many universities involved. At the same time, you have Innovate UK funding projects used to be called teaching company projects. Now they are called knowledge transfer partnerships. Some of these projects can be for manufacturing. In fact, many of these projects are related to manufacturing. Then the very recent program by the Innovate UK people is the Circular Economy Hubs and hub and centers. And this is a 30 million program. And of course, you have heard about the High Value Manufacturing Catapult, which consists of a number of centers. In Coventry, there is a center known as Manufacturing Technology Center. In Sheffield, there's AMRC. In Warwick, in Coventry, there's the Warwick Manufacturing Group, and they are part of this High Value Manufacturing Catapult. And you can work with these catapults. You can get PhD support from them. Then there are other sources of funding for research, ERDF and regional funding agencies. They do not actually support research, but they support the transfer of technology to help companies. And if you are clever, you can still use some of this money to support research. If that research leads to practical help to help companies to grow. And there's the Royal Academy of Engineering, which does not support only research, but people do get research chairs in manufacturing, or senior research fellowships in manufacturing, or research fellowships in manufacturing. Also, there are chairs in emerging technologies from time to time, and some of these chairs are also related to manufacturing. So this is the general landscape in funding in the UK over the past 40 years. Now, currently, the EPSRC is focusing on three things. The first objective of EPSRC is very relevant to us, and it is to do with productivity. I mentioned before that the UK has now a focus on improving its productivity. So if you have a grant, a proposal that is aimed at helping the UK to improve productivity, then EPSRC is a good potential source of funding for you. Another area EPSRC is focusing on is digital manufacturing, connecting businesses and companies using digital technology. So this is a very important area as well for funding. Now, with the pandemic, resilience has become important. So resilient supply chain, resilient manufacturing, this is now an important topic. So these three areas are important for manufacturing. This is more for people, and this is more for infrastructure and the organization of EPSRC. So I think when we apply for funding to EPSRC, we need to focus on these items at the top. In terms of the budget of EPSRC, manufacturing occupies a big part of the budget of EPSRC. They support about 80 million pounds of research each year in manufacturing. The total budget is 800 million. So it is about 10% of the total budget. Design is also related to manufacturing. And you can see here, E is for energy. Some of this is also spent on manufacturing. Quantum technology, some of this could be related to manufacturing. And ICT, some of this could be related to manufacturing. Within EPSRC, the main theme for manufacturing currently is manufacturing the future. And these are areas under manufacturing the future. You see, manufacturing technologies is a big area, big part of manufacturing the future. The total number of grants in manufacturing the future is 262, and the total value of the grants is 350 million. So large amounts of grants in manufacturing. Now you want to see where all this money is distributed. In the UK, it's quite evenly distributed with a concentration in Humberside and Yorkshire. So this is where most of this money goes. In the Midlands, there is currently not so much. East Midlands, yes, quite a bit of money. And Manchester area, also quite a bit of money. My own journey now. This shows you my lab in New Zealand. At the end of the 70s, I finished my PhD. And my PhD was about robotics. So my purpose at that time, my main task was to design and control a device to help robots perform assembly operations. So this was a table, 6 degrees of freedom table, which I had to control. So I had to build all the electronics here, connect to the computer, which is downstairs. This was on the first floor in my lab in New Zealand at the University of Canterbury. So I'm a mechanical engineer. I had to spend about 4 years working on this to design the control system and so on. So I became quite familiar with computers. When I did my undergraduate, I never managed to write a computer program that worked. But when I did my PhD, I had to change all that. I had to learn machine code programming, assembly language programming, and high-level programming in Fortran. So I learned all that with computer interfacing and building of electronics. So that was my background, my PhD background. And also during my PhD, instead of working on that computer control device, I also worked, or in addition to, I also worked on a device to be mounted at the end of a robot arm. This was an early robot arm. The device was a passive device, completely passive. It has also 6 degrees of freedom, but it was not actively controlled. And it enabled this robot, which had an accuracy of 1.25 millimeters to perform an assembly operation requiring or having only 50 microns in clearance between this pin and the hole. So using this passive device enabled this particular operation to happen. Now, when I came to the UK and during the robotics initiative program, I was able to obtain my first grant. This was my first grant. And instead of focusing on building robots, the grant was for building grippers for robots. Now, grippers, they are simple devices, but they can cost quite a bit. They can cost 20% of the cost of a robot. And if you need many grippers, then soon the cost of the robot will be exceeded. So my aim at that time, or our aim, was to design and develop versatile grippers for robots, grippers that could grip families of robots. So that was a mechanical part of my PhD. Then also, as part of this project, I worked on a knowledge-based system. So to help design and select robots, grippers for robots. And given an object, we were able to select the right place to grip the object and the right gripper for it. So that required a knowledge-based system. So that was my first grant, my very first grant. Then during the ACME program, I worked on, I had a grant working on inspection of seals. So these were seals, they were small. You know, if you imagine your 20p coins, they are about the size of the 20p coins. Now, at that time, a local company was working with BMW. They were suppliers of seals to BMW. They supplied a batch of seals, 10,000 seals. One of the seals was faulty. BMW rejected the whole batch. So the company was very worried, and they wanted to implement 100% inspection. So they went to us, and together we went to EPSRC, to the ACME program, and we obtained a grant. And this was my grant to work on this system. We developed a system with different cameras, and it again used knowledge-based technology for its operation. Then IMRC. At the time, I was the director of this center, Manufacturing Engineering Center at Cardiff University. We collaborated with people in the business school. I mentioned to you that business schools were also getting grants from EPSRC, and they got quite a few grants. And together with them, we went to EPSRC and we managed to secure funding for the Cardiff University Innovative Manufacturing Research Center, which ran for 5 years. During the time of the Cardiff University Innovative Manufacturing Research Center, we also obtained funding from Europe. So far, I've not mentioned anything about funding from Europe, but we also obtained funding from Europe to run a large network of excellence. By large, I mean it had 30 organizations from 15 countries in Europe. And we in Cardiff were the coordinator of this network. It was 7.5 million euros. So for that time, it was also a large project. Now, this is my most recent project. It just finished a couple of months ago, and the project was to do with remanufacturing. The EPSRC wanted a program of research in the area of autonomous manufacturing. We went to them and we said to them, we wanted to work on autonomous remanufacturing. So this was the project. And you can see that my experience of 40 years ago, working on putting a pin into a hole, was used in this project to enable robots to pull the pin out of the hole. So I started my career by putting pins into holes, and towards 40 years later, we work on pulling the pin out of the hole. We look at disassembly science. My PhD was about assembly science, and recently we've been working on disassembly science. And we look at strategies enabling robots to perform disassembly. We look at planning using optimization algorithms developed by our lab to perform disassembly. We look at human-robot collaboration in disassembly, and we constructed quite a few demonstrations. You can see them on YouTube. So some final observations. Funding priorities are cyclic. In the 70s, funding stopped for AI. In the 80s, there was funding for AI. In the 90s, funding stopped for AI. And in the 2000s, AI has become important again. The same with robotics. Robotics is now very important, whereas in the 90s, robotics was not considered the in word. So that's something to remember for researchers. Funding priorities are cyclic. Grant successes are non-ergodic. Now, we know that they are random, but if you look at, say, EPSRC, they say the success rate is 20–30%. It means that from a total of, let's say, 100 applications, about 20 or 30 applications are successful, which is correct. If you look at the total set of applications, if you look at an individual applying, then probably the success rate is not like that. The success rate can be higher, can be lower, depending on the person. So that's what I mean by grant successes are non-ergodic. But it doesn't mean that you can stop applying, because if you don't apply, the chances will be zero. So you need to put in applications, but you need to ensure that your applications are strategic. Strategy can still bias the game and can still increase your chances of success. EPSRC favors big grants. They find that they spend a lot of time administrating small grants, so they favor big grants. But also nowadays they come back to favoring also small grants, but innovative grants. You need to be collaborative if you want to go for big grants. So I say collaboration is king. And interdisciplinarity is what EPSRC looks for. And with interdisciplinarity, you can achieve some new ideas. EPSRC doesn't like Me Too research. So if you want to get EPSRC funding, you need to come up with something novel. And often novel things come unexpectedly from the left field. For instance, most people, when they tried to compete for this autonomous manufacturing program, they went let's say 90% of the efforts were into autonomous manufacturing. What I thought at the time was different was autonomous remanufacturing. So I went to them with this proposal and it was accepted. And as researchers, we must be prepared to switch fields. And you can see that business people can come into engineering. Why not engineering go somewhere else and invade other people's spaces and become cuckoos and get funding? So in conclusion, I've exceeded my time. I'm sorry, Juan. But manufacturing is important. And there is considerable support for manufacturing research in the UK, as you can see. Funding is becoming concentrated in small numbers of centers. But opportunities always exist if you have truly innovative ideas. Thank you.
Amazing talk, Professor. Yes, a bit over time, but it's absolutely okay. Hopefully we can manage to get some time back later on. But you already answered quite a few questions that some of us may have in mind in the last couple of slides there. I'm sure that we still have many questions, but maybe I just ask everyone to put that on hold later on in the panel section. And then we can, even myself, I want to come back to quite a couple of questions. Yes, with that. But now, thank you again, amazing talk. And hopefully it stay on with us. And then we can have the panel later on where we got a bit more time to discuss and ask for more questions.